Hi guys, welcome again. Vijay speaking, and very good morning to the guys who are joining us from US, and good evening to the guys who are joining us from India. I just logged in some time back, did a quick sound check, and was just waiting for the guys to join. By the time, I just need to tell you, in last 4 minutes, there are more than 50 people who have just joined us here overall. So welcome guys to this session on Spark and Scala. My name is Vijay, and I'm going to continue this session. I'm sure, though I have already done the system check and all just a few minutes back, I hope all the guys are able to listen to me, including the guys who have just joined us in last some 3 or 4 minutes. Right? Indrajit, probably Indrajit, Shivram and all. I hope all of you are able to hear me. Thanks a lot guys for confirming. Sure. So guys, let's get started quickly. Okay, so before we start on what is Spark and what exactly are the things and all, let me just give a brief review about the course, about my background, and then we can just get started. So guys, about Spark and Scala, of course, this the kind of things which we plan to cover today is I would say, in terms of the objectives of this session, is all to understand what exactly Spark is, to understand why exactly it is important. When I say important, again, it's not really a sales pitch wherein we are trying to sell a course to you. No, it's more from the perspective of what exactly differentiates it from the other so-called big data systems, and where exactly Spark draws its main power, and how powerful or how useful it can be in certain scenarios when it is kind of integrated with some systems, right? Of course, it's quite a lot to talk, right, within 1 hour, but of course we'll just try to touch upon those things. And if at the end of the session you are having a good understanding of what exactly are you trying to deal with, that would be a big takeaway. And in Edureka, we never believe in just talking. We don't believe in just going on the PPT side of it. We try to back it up wherever possible with examples, with some sort of hands-on and all. Even though it is just 1 hour duration webinar, it is also not an exception. So I will try to give 1 or 2 demos wherever it is possible, on 2 specific components altogether, just to give you a real feel of how exactly the things work, and how exactly the things would work when if you decide to attend the course. So that's about the objectives, and the object now when it comes to my profile. So as I told you, my name is Vijay, and I'm having now I think more than 12 years of overall experience. Yes, that's how it is. And this is 12 years, I think, since last 5 years plus now, I'm working in big data domain. And when I say big data domain, my journey started in Hadoop accidentally. We were working in a startup and things like that, and have worked I think for almost 2 years or 3 years continuously into that. And then over the period of time, I have started involving myself into the real time or near real time systems like Spark. There is something called Storm. There are a few other systems on which I have worked, and then eventually I find myself doing more of the integration of these big data systems with the enterprise systems. Typically, people call them as the Lambda architecture implementations, and that's what you can say that, yes, this is my specialization. When it comes to the domains perspective, the functional domains part of it, so I think the most of the exposure goes towards the retail industry and the finance domain. When I say finance, specifically into the banking side of it, there are a couple of projects which I have done for telecom domain and healthcare as well. But again, they are like negligible as compared to the overall exposure to the other domains. So I think that's pretty much about my details, and we can always explore more about those sites as and when we'll keep going in the course if you decide to attend that. So that's good enough. Are we good, guys, to continue on the the coverage and all, right? Okay, with that, let's just get started. So guys, did you just notice there is nothing called objectives of this session? We have purposefully removed that because let it evolve. Let it evolve is the idea altogether. So coming directly to the point of the crux of the matter. So we are all here. You are attending this webinar. Probably you are already an existing customer of Edureka, and you got some sort of webinar thing. Or probably you must have heard about the real-time systems, or probably in your organizations they might be talking about near real-time or real-time big data systems altogether, and Spark must be one of them. Of course, the number of people who are attending it is so much that I cannot afford to get each and every of your responses, but I'm sure most of you who are listening to me can correlate your situation with that, right? Somewhere or else it must be it must be matching with your the present conditions altogether. So let me just first talk directly what exactly is Spark altogether. So if you have heard at any point of time, if you have heard about Hadoop, right? Hadoop is kind of a framework, right, which allows you to do the distributed processing, but that framework is specifically suited for the batch kind of processing altogether, right? Batch processing operations. However, when it comes to Spark, again, Spark is also a framework. First thing, it's a parallel data processing framework, just like Hadoop. It is open source, just like Hadoop, and it complements Apache Hadoop to make it easy to develop whatever that fast unified big data applications. By the way, overall point is it tries to complement Hadoop by making the operations whatever happen under Spark as near real time. When I talk about near real time, if you are trying to perform some batch operations, they are the fast batch operations. If you're trying to do some sort of streaming operations, it does live streaming operations altogether. So the typical use case of Spark is just like Hadoop. You can do the parallel processing in the cluster of machines. Only thing is your operations are going to be much faster, and they are more inclined towards the near real-time operations as well as the interactive analysis, which typically your data scientists prefer. A bit background about it. It was developed as kind of an educational project in UC Berkeley, and then over the period of time there is a company called Databricks which took it, developed it, and then eventually they donated it to Apache community as the open source project. This project went into the incubation somewhere in 2013 end. I think, no, not 2013 end, even 2014 start. And by the end of 2014 itself, or even before that, it became the full-fledged top-level Apache project. This is the only project, I mean, this is the project which gained this. I'm not sure if how many of you are aware of the hierarchies. So typically you have the incubation, then you become a sub-project, then you become a, you become the part of a project, and then eventually you become the overall, top-level project of Apache, depending upon how much traction it generates. Hadoop, right? I'm assuming that those people who are attending it, by default, at least they would have heard about Hadoop. If they don't know about it, they must have at least heard about it. Hadoop, which is kind of a benchmark right now in industry for the batch processing of big data, took almost 2 years plus to become a full-fledged project. This entire Spark framework took less than a year to become the top-level Apache project. that itself should tell about the kind of traction. That itself should tell about the kind of importance which Spark is finding in the overall enterprise architecture of the systems. The main power which Spark gives you is the generalization of the MapReduce framework altogether. So I'll talk about this point in a bit more detail in the coming slides. Right now, just keep it as a placeholder in your mind that the biggest power which you are going to draw from Spark is the faster batches and the generalization of the MapReduce concept altogether. Okay, so what do we mean by that? Let me just, you know, delve deep into those things. Okay, so I hope everybody is good about what exactly Spark is. Am I right in assuming so, guys? Are we with the understanding of what exactly is Spark? Of course, answering each individual question might not be possible, but I would like to, you know, clearly understand what exactly is the opinion, and you know, nothing stops you from typing it. What do you guys say? I just got 3 responses so far. All right, right. So this is about the Spark. So Spark, at the end of the day, Spark is going to be a framework which is going to allow you to do the real-time or near real-time processing of the big data, you know, which is at your disposal through the distributed systems altogether. Now comes, if we know what exactly Spark is, right? What exactly Spark is, then the question of why should I even go for it, right? Because there are enough big data systems already, and Hadoop is kind of a benchmark, or you know, altogether for big data processing, batch processing. Why should I go for Spark? The first reason is the speed factor. Of course, everybody wants the, even if it is a batch processing, everybody wants the speed factor altogether. So in some cases, I'm not going to say that in all of the cases, no, this is not the blanket statement which I'm giving. Point is, in some cases, the performance of Spark programs is almost 100 times faster than the equivalent MapReduce programs, Hadoop MapReduce programs altogether. So Hadoop MapReduce programs typically read the data directly from the disk, manipulate it, and then they persist the data into disk. Whereas Spark follows a bit different methodology. More details on it when, you know, so right now, basically it works mostly with the in-memory operations, which are many times faster as compared to reading the data from the disk. That's the basic thing. How does it do? That's a part of, you know, that entire course in terms of the RDDs and other stuff. I'll briefly touch those things in the coming slides. So that is the first thing itself, the speed factor. Is this the only factor? No. The other important factor is the ease of use. When we say ease of use, it's like, so let's talk about Hadoop. You know, with Hadoop, the best thing is, or best or worst, depending upon from where you are looking at, if you're a very good Java programmer, right, your life is much easier in Hadoop world altogether, because you can write Java MapReduce programs and all. But even if you're not a Java programmer, let's say you have worked typically on Python, or you are coming from the background of Ruby and things like that, you can still write your MapReduce programs using something called Hadoop streaming. Similarly, for any framework to become popular with the wider developer community, it has to support multiple languages, right? I hope everybody will agree with this part. And Spark is no different. Spark, you can create your programs as of now using 3 languages: Scala, Java, Python. The entire Spark framework itself is written in Scala language, and hence we'll be covering Scala language in the actual course. I will touch on those parts at the end of this you know, presentation itself. But as of now, the support for these 3 languages is provided out of the box. However, it is not the end of it. In the future footprint altogether. So in fact, day after tomorrow, I'm going to have a meeting in San Francisco with one of the revolutionary analytics guys who are developing the R. R is a statistical programming language. So R components for Spark. Okay, so they are going to call it as Plier Spark basically, or Spark R. Okay, so it is kind of in the beta release and all. So anyway, the idea is overall that Spark itself is extending its functionality to multiple languages. So you can explore it using Scala, using Java, using Python, even very soon in future using R. Even there is a language called Clojure. So there is a parallel development which is going on in that direction also. But again, all of those who be it R or Clojure, they are not yet in production. The active development is going on those sides. That is another important thing. Another advantage which you get out of a Spark is the idea of generality altogether. When I say generality, so guys, Spark, as I just told you, what is Spark? Spark is something which is allowing you to do near real-time analytics of big data, right? That's what I just told. Spark is not the only one which does it, by the way. Spark is not the only system which does this thing for you. There is a system called Apache Storm. Okay, again, from the Apache stable, there is a project called Storm, which does nearly the same things. Okay, there are other systems also. There is something called SAMZA, and there are others also. Okay, which typically do this near real-time processing. However, the place where Spark gains clear-cut advantage over any of them is it provides you the generality. It provides you the framework altogether. So what really happens is, if you look at the third column right now, right, generality, and there is a small figure here, right, which says Apache Spark. At the bottom of it, Apache Spark is kind of a foundation, and then you are having Shark, then you are having Spark streaming, MLlib, and GraphX. I will show this particular figure in bit more detail in the coming slide. But however, right now you have to understand there is this Apache Spark engine altogether, which is the core engine. And then if you want to do some sort of machine learning, there are machine learning libraries which are developed on the top of it. If you want to do some sort of graph processing, there are GraphX. There is something called GraphX, which has been developed on the top of Spark. You want to do some sort of storm-like operations, like streaming-like operation on the data, you can use Spark streaming. You want to use some sort of Hive type of operations, you know, right? In Apache Hadoop ecosystem, there is something called Hive, which gives you SQL-like functionalities, okay? So you want to do that kind of analysis, you can use Shark. Actually, Shark is closed. Now it is called as Spark SQL. So you can do all of those things, and hence this generality concept of Spark gives it a clear-cut advantage over any of its competitors, because it exposes itself in the form of, you know, be it streaming, be it MLlib, be it GraphX, depending upon the kind of users who would like to explore it, right? The advantage is it has got very good integration with Hadoop. So Spark can easily be integrated with Hadoop, either as just the backend storage or as the execution framework itself. So Spark itself will just be a process which will be running on your Hadoop cluster. That can easily be done. There are other execution engines as well. There is something called Mesos. Apache has got the direct interaction with that. However, in the course, in this course, we will be exploring the integration of, so we will be exploring Spark in detail, as well as we will be seeing how to integrate Spark with Hadoop, both as the storage as well as the execution engine. So that would be something which we'll be covering. Are we good with this point? The main reasons of Spark, the things which give Spark a clear-cut advantage over its competitors. Are we good with that, guys? Right? I know at this point of time, getting 100% clarity, of course, it would be like too much to ask, but you should, you know, be having some idea which is better from 10 minutes ago, right? So that is something which is one of the reasons of using Spark. Well, this particular slide definitely assumes that you should have some idea of MapReduce. So guys, those guys who do not have any idea of MapReduce, I will quickly, within few minutes, I will just tell you, MapReduce is actually a paradigm. Okay, it's a paradigm. What do you mean by a paradigm, by the way? So if I say that, you know guys, there is a particular file. I'm giving a file. In that file, there are 2 columns, okay, or probably 3 columns. The first one is the roll number, second one is the name of the student, and third is the overall marks scored, okay, in whatever class. Now I want to know the topper of the class, or whatever, top 5 guys of the class, right? If I tell you this, I'm sure those 100 plus people who are attending this webinar, in this batch itself, there would be some people who would be coming from SQL background, right? There would be some people who would be coming from Java or any of the programming languages background. So the SQL guys typically will say, you know what, it's not a big deal. I'm going to expose it in the form of a table. Then I'll just fire my some select query. Similarly, those guys are coming from a programming background, they will just say, well, it is just a simple file. I will just load it in the memory in the form of a collection, either in the map or in some sort of a list or something. Then I'll just apply the sort function and will give you the top whatever n, and it's a parameterized program. Are you guys getting it? So both of you, can I say the SQL guy is wrong? Or can I say the Java or whatever other programming language guy is wrong? Both are correct. And we call it as the paradigm. That's what we mean by the paradigm. Is that clear when I talk about it? So similarly, MapReduce is a paradigm. It is a way in which you do your calculations. Basically, it assumes that you should be able to express your problem statement in the form of key and value pairs. More on that, it's a big topic. So more on that when we'll talking in terms of the actual course. But however, MapReduce, this became a very famous, or it is one of the very powerful kind of paradigm to solve a lot of problems in big data world, and especially in Hadoop world altogether. So MapReduce is a great solution, okay, specifically for so-called one-pass computation. When I say one-pass computation, basically write it once, read it many times, sort of, right? So you have to pass through data set once, and whatever kind of calculations you are trying to do it all together, okay? So it is very good. But remember, if you have to perform any kind of operations which require you to do multiple pass of the data set, it is not really a very good one. The best examples of those algorithms which require you to do the multiple passes of the data set are the machine learning kind of algorithm, wherein let's say you are doing some sort of clustering and all. In order to do the clustering, you might have to run the very same algorithm again and again on the very same data set and keep on running it to a certain iteration. So MapReduce is not really very good for those kind of things. There are other things. If there are complicated jobs wherein you might have to write multiple mappers, multiple reducers and all, you have to go for the chaining of the MapReduce jobs, whatever you are seeing as a second point, series of MapReduce jobs, okay? So again, you end up creating those sequencing issues altogether. Also, the fastest response time in the MapReduce jobs is going to be minimum in the order of seconds. So just the overhead of invoking the MapReduce job, invoking all of your the mapper task, reducer task, getting the data out of that and combining that itself takes several seconds to complete. So again, you're talking order of seconds. This is the fastest one. And the longest running jobs, well, I've seen some of the jobs running for 3 hours, 4 hours also in production. Okay, so the kind of latency which we are talking at this point of time is really very high, right? The other important thing, if you're going to do the chaining of the MapReduce jobs, okay, the chaining of MapReduce jobs means the first MapReduce job, once it is over, the second MapReduce job will not be able to consume the data of first output until and unless you materialize it. You save the data on the file system. Well, it is saying as local file system. I'm referring to the second last point right now. Each step has to be stored in the local file system. You can say local/HDFS, Hadoop distributed file system. So the overall net, the message which I want to convey is MapReduce is very powerful, though it has got high latency. However, when you go for the complicated kind of algorithm where you have to do the multiple passes or chaining, it becomes completely unusable because your downstream applications or your downstream MapReduce jobs will not be able to consume the data until and unless you persist it. Okay, so there is in-memory transfer altogether. And of course, last point, I don't really agree very much with it, but it is true that if you really want to do iterative algorithms and things like that, you have to add Mahout and Storm for the stream. So all of those add-ons are required on Hadoop. Whereas with Spark, all of these things you will see in coming slides will come pre-packaged as part of your framework altogether. So I would now that I have spent the time, in this industry and in this area since quite long, I would say Spark has evolved the learnings from Hadoop. Okay, so whatever were the missing points, they were eventually added, and that's where I hope you remember I have told you that Spark has actually generalized the entire Hadoop framework. And I hope now you are able to understand what I meant by that. Your overall learnings, whatever were learned, basically they are now incorporated in Spark framework. Right, guys? Is that clear? Are we good with that? Right? Sure. Okay. Now, let me just continue with the next topics here. So, some of the features of Spark altogether. Well, at this point in time, I don't really expect you to understand the features because some of them definitely require you to invest the time in the hands-on, and then we'll to understand. But I'll try my level best to correlate them with the existing understanding. So the first thing first is Spark basically takes this MapReduce paradigm altogether to the next level with the concept of something called RDD. I will touch base on things very quickly in coming slides. But RDD is all the resilient distributed data sets, and basically this Spark ensures that your data processing, if you remember in the MapReduce, the most expensive part is the shuffle and sort, and it basically saves on those operations because those operations here typically happen only in the memory in the distributed fashion, and that's where Spark has most of the power of it. Okay, the next thing is Spark again doesn't execute your entire job as it is at any point of time. Hadoop does not Spark does not really execute your jobs as it is. They are evaluated lazily. It has got a lazy evaluation wherein it just creates the data flow altogether. It's just like Pig. Those guys who are aware of it, it creates the directed acyclic graph and all. It keeps them in memory, but it performs the computation only when you really need the result. Okay, so those are some of the things. You can see that point number 2, point number 4, basically they are all correlated. Another point is whatever execution you are doing, it gives you a flexibility that the results of those calculations can either be stored completely in memory or completely in disk, or even you can specify the percentages. You can, well, you know, this result set, let's keep it all in memory. Or you can even say, so there are like different persistence levels altogether. So in memory being the fastest, on disk being the slowest. And it's not like these are the only two options. You can specify the percentages, and accordingly your fetches of the result set can be, you know, fastest to the slowest one, right? So it gives you that kind of flexibility altogether. Now, the other important thing with Spark is, as I just told, it is just a repetition of the same point, that Spark has provided this APIs for these three languages: Scala, Java, as well as Python. And for Scala as well as Python, it even provides you the interactive shell. You know, right? Those interactive shells like IRB, like Python, and like Scala and all. So it just provides you the interactive shell, wherein you do your ad hoc analysis very quickly. The advantage of your interactive shells is, if you have made your code work on the interactive shell, it is definitely gonna work on your application. So it just provides you that flexibility of doing the ad hoc analysis very, very quickly, even for productionizing your job, right? Java, of course, it does not provide the interactive shell yet, and that doesn't make sense also, right? Because Java is a compiled language, right? And Spark provides the high-level APIs to develop the applications, as I just told, Scala, Java, Python, yes. For Closure and R, they are still more like work in progress, sort of, right? So these are the different features of Spark. With that, if you guys remember, some minutes back I was telling you that there is a Spark architecture. You know, I will be covering that very soon. This is something which you can call, the screen which you are seeing now, slide number 6, is something which you can call as the architecture of the Spark ecosystem altogether. So at the end of, at the base of this entire architecture, you have the Spark core engine. The core engine basically is the which is responsible for executing your program. Now that Spark program you written completely in the form of program. You have written that program in the form of a streaming job. You might have written that program in the form of a machine learning kind of library, which is called MLlib. That's, you know, or probably you're doing some sort of graph operations, then graphics. Spark R, well, it should have been in the orange color. By the way, this orange color means these versions are not yet released. Okay, so Spark R is not yet released. BlinkDB is not yet released. Okay, so Spark R, basically it is for all of those R operations which can work along with Spark. So that would be the extension of Spark. It is not yet released. BlinkDB, well, has anybody heard about the approximate databases? Has anybody worked with them? I'm not sure how many of you, because it's kind of a very new thing in which we are working in SF right now. Not yet? Okay, let me just give you a very quick understanding of those things. Guys, when it comes to you know, the approximate databases, it's like very soon you had the IBL in India, right? Well, just some time back. So there were a lot of tweets and tweet counters were being published. Do you remember? I'm sure some of you would have been cricket fans and all. Okay, so at that point of time, right, so there were some of the tweet counters and all. Now guys, tell me one thing, are you really interested that there are 300,500 and some number of tweets which are there? Or are you good to know that the overall number of tweets are more than 300,000? Right? So what I'm just trying to say is, these are the kind of databases which basically give you the approximate result. They do not give you the exact result. So let's say you are firing a query on a big table which says select count star from table X. If it's a very small table, you would definitely like to know the exact number of records. Whereas if it's a huge table, billions and billions of record, you would like to know some approximate results. Okay. So it is always trade-off. You trade off the accuracy with the speed altogether, right? And you try to hit the sweet spot somewhere between them. BlinkDB does exactly that. It will be released in some more time. I mean, so some of my friends who are already working in this direction, like it will still take. There is still a long way before it gets released. But yes, that's the whole idea in which BlinkDB is gonna, come into picture. Excites you guys, right? So this is why I call it Spark as the framework, or that's where Spark gains its importance in terms of exposing its functionality in the form of multiple plugins altogether, and each plugin trying to do various things. Well, till now, if you see, this is something which we just covered, right? The top part: BlinkDB, Spark SQL, Spark Streaming, MLlib, Graphics, Spark R, and Spark Core. This is the base Spark architecture. What are these two? Cluster management and distributed storage. So guys, Spark in itself is a framework which is helping you to do the things. But what is the advantage of a Spark if you cannot run it on a cluster? Are you getting the point? It might be supporting it, but you need something, right? You need to run it on a cluster of machines. That's where you will get the power, right? That's where you will get the power of parallel processing altogether. In order to do that, integrates, okay, supports integration with three things. The integration is, the first one is the native Spark cluster. So you don't want to use any Hadoop, anything. Go ahead and use Spark's own cluster altogether. Or you can integrate Spark with Yarn. Okay. When you say I am going to integrate Spark with Yarn, it means you are using Yarn as the backend engine, the actual execution engine, and Spark will just be a process which will be running. There is one more way in which you can integrate Spark with Hadoop just as the storage, and in order to do that you don't need Yarn. Okay, so more on that, when in the course I will be covering about how to integrate Spark with Yarn and things like that. You will learn more about that on a later date. Then there is another cluster manager called Mesos. It is just like Yarn. It's another cluster manager called Mesos. You can integrate Spark with Mesos also, and you can run it on the cluster of machines. Now, this is only from the cluster management perspective, but when it comes to the actual storage, so those cluster managers basically these cluster managers manage the distributed storage. It might be HDFS, or it might be HBase, or even Cassandra or S3, or any of those storages are also supported. Okay, so this is just the extension of the very same Spark architecture which I just discussed. It is just the extension part of it, nothing much. Okay, now let me just continue on the Spark advantages. By the way, just want to know from you guys, are we all good? Going good? And are you all able to hear me properly and things like that? Now that we are just kind of somewhere in midway, I just want to know a very quick feel from you guys. Thanks a lot for confirming, guys, quickly. Okay, with that, I'm just trying to now evolve more into the direction of the advantages. So Spark advantages are clear. So in the course, in the actual course, I will be showing you the integration of Spark with Hadoop. But in order, in order to do something, you should definitely be aware why are you trying to do something, right? I mean, if I just ask you, just learn MapReduce, you will definitely ask me, what is it which I'll get out of it, right? So right now, in these 2-3 slides, I'm just trying to tell you Spark plus Hadoop integration. Yes, it will be covered in the course, but why are we even spending some hours to it, right? That is something which I'm trying to cover now, right? So guys, some of the advantages, Spark advantages, now should be new. The ease of development, because you are supporting multiple languages, your APIs are easier. And by the way, what is the biggest advantage of Scala? Anybody who has worked with Scala? Or let's say even with Java 8, there is a difference between Java 8 and the previous versions of Java. What are the biggest advantages of these two languages? What is the biggest advantage? Biggest advantage is the functional programming. The functional programming aspects which are now developed. Okay, so they are the biggest advantages, right? And what is the advantage of functional programming? I'll not go much into the detail, but right now all I would just try to say is, with the newer APIs, your programs become much more concise, lesser verbose, and much easier to maintain. Not to mention that your concurrency issues and other things automatically go away with the functional programming. Okay, so those are some of the things which will be covered in the actual course, but yes, these are some of the things which make your life easier as a developer. Okay, now this is the first advantage, ease of development. The second advantage is in-memory performance is much better. When I talk about in performance, see, there is a concept of RDDs, resilient distributed data sets, and the directed acyclic graphs all together. So all of this happens in memory. And the other important thing is, all of this, as you saw, that your Spark core engine could be expressed in the form of MLlib, GraphX, etc. So all of these advantages you get via Spark, right? Now, let us quickly look at the advantages of Hadoop altogether, right? So now, what are the advantages which you get with Hadoop? The biggest advantage is you get the unlimited scale, right? Horizontal scalability. I'm not going to spend much time on Hadoop advantages, right? Enterprise platform, people are already using it. It has matured over the period of time. It has definitely better security aspects and things like that. The wide range applications altogether. Of course, that's a platform which supports any kind of unstructured, structured, or semi-structured kind of data analysis altogether. So these are the advantages of Hadoop. If I marry these two, this is what I get. I get the ease of development at the unlimited scale. I get the in-memory performance on the enterprise platform, and I get the wide range of applications which can be developed just by combining the different workflows, right? Very easier said than done, but this is the best way in which I can justify the integration of Spark and Hadoop. Spark per se, just per se, if you really want to say, I want to work in Spark, I don't care about Hadoop, you are very well. You are very right saying so. However, if you want to take your application to the enterprise level, you have to go to Hadoop, or you have to leverage the power of Hadoop, right? So just hope this, just keep it as a placeholder that yes, this is where some sort of integration really helps altogether. Okay. Well, there are some of the questions which are coming, and guys, if it is going to be 10 instead of 10:30 India time, if it is going to be, let's say, 10:30ish, I hope it is okay. I'm just trying to deal with the things in a bit more detail, right? I'll just take 1 or 2 questions. Somebody says, do we need to know advanced Java, or the basics are fine? But you don't even need to know Java, because there is something we'll be covering it in Scala, and I'll tell you very soon how do we plan to. Okay. for real time we have is how it is different. Well, this is again a recurrent question. Base is just a database of Hadoop. It is not going to do any kind of streaming. For example, no kind of streaming operation can be done via HBase, right? No kind of machine learning can be done via HBase, right? So just you know, some of the things, right? Okay. Well, there are other questions, guys. There is a proper Twitter handle which we have, so I'll quickly share. Sorry if I'm not answering all of your questions. I have to take care of the time also, right? But I'm trying my best still to answer most of the frequently asked questions, sort of. So resilient distributed datasets, guys. Resilient distributed dataset is the backbone altogether of Spark. Nothing. There is absolutely nothing in Spark which can be done without RDD. Every single thing in Spark is actually the RDD. RDD stands for Resilient Distributed Datasets. When I say resilient, it is the, it is resilient to the failures. So since the data is in memory, and you know that if the memory is gone, your data is gone. How it is resilient? If memory is gone, you can reconstruct this data. How? We will see that in the class. It is distributed. So it is not that your entire data set is available in one memory, in one machine. No, your data set is present in multiple machines, and hence your memory is also distributed across machines altogether. That's the biggest advantage. And the best thing is, you as a programmer, you don't have to worry about it. You just import the right class and you get it for free. Okay. Next thing, it's a data set. Of course, it is a data set. Basically, it just keeps that all in the memory, and that is it. You can load the original data either from a file, or even you can create programmatically, or even you can get via streaming and things like that. So it's basically the core component altogether. It can keep any kind of data, typically any kind of data, either any kind of primitive data or any kind of data from the files and all. It is fault tolerant, and at the same time it is immutable data. Well, I will not go into the details of it right now. Okay, I will not go into the detail of it, what are the advantages or why it is immutable. Right now I will just give you one line. Guys, this immutability of RDD makes it thread safe. Okay, it makes it thread safe. Right now all I would just say is this much. More on that, in the actual course itself. So there are two specific kind of operations which can be done on the RDDs. Typically, the kind of operations which can be done are kind of the transformations and the actions. Typically, when I talk about the transformation, let's say you are loading a particular file. You want to convert all of the lowercase to the uppercase, right? This is what you mean by the transformation. When we talk about the action means you are performing some sort of function. When I say function, let's say, add the value of all of the columns, right? All of the values of a column. Now this is something called as an action altogether. And RDDs actually execute your code only and only when you ask them to perform an action. Till that time, they just keep themselves as calculated. That is it. Okay, so don't worry much about it. The action operations and all, we'll cover them in bit more detail. Well, the time to do a very quick demo of RDD. Okay, so we have talked enough about it, and I'm sure it is not really the right time to go through into the in memory or RDD and stuff. We don't quick look of how does it work, and then I'll quickly talk about Spark and we'll quickly see them in machine rather than talking about it. Okay, so hold on, guys. Well, this is my virtual machine, which is the Cloudera 5.3, which I have installed, and we'll be giving you more details about it when when we'll be talking in course. Well, right now, very simple. I'm not even going into the installation part of it. say you have to fire up your Spark. Just type Spark shell. Okay, just type Spark shell and press enter. That it will fire up your entire Spark interactive terminal altogether. Okay. Now, what I'm trying to achieve is, I'm sure, and forgive if my assumption is wrong, I'm sure most of you people have heard about MapReduce, and most of you have heard about the word count program, right? Word count and MapReduce. Can somebody confirm that yes, you have seen MapReduce program executing? Word count MapReduce program at least seen executing. It doesn't take more than saying yes on many times, right? So guys, how many seconds does it take with a file with let's say 1,000 entries? How much time does it take on your single machine altogether? 16 seconds, few seconds, right? 1 minute. There are some people who say 10 minutes. No guys, 10 minutes your machine very definitely not take fraction of a second, guys, for sure. Okay, it definitely takes around kind of 40 seconds is the usual time which it takes with 1,000 entries. Okay, almost 1,000 entries. Now I'm going to take the very same thing. I'm going to perform the very exact operation, because right now I can take the leverage that I'm not going into the logic. But all I'm just telling you is just showing, I'm going to show you how does it work altogether. Okay, and especially those guys who are saying fractions of millisecond, guys, let me tell you, it cannot take fractions of millisecond until unless you are not running it on MapReduce. You might be running it on the local mode of MapReduce. Okay, if you run it in a full-fledged in a demons thing, 30 seconds to 40 seconds is the minimum time which it takes. Okay, now let me just tell you what I'm trying to achieve. So guys, this is a usual file of names. You see some names. Okay, Vijay, Sumit, and something which repeated times. There's more than 1,000 words in this. Okay, it's a big file. Okay, so this is my file, and I have fired up my Spark shell also. Okay, now let me just do some things very quickly with you. Okay, so guys, my first thing right now, please do not worry if you do not understand the text or say right now properly. Right now, please understand, I'm creating a variable called, or value, I don't call it as variable, I call it as value, called text file, which is based on the names.txt. This is something which I have just created. Next, you must have seen word count programs, right? How big are they? 40 lines, 20 lines. This is the word count program in Spark. Are you seeing this? Are you seeing the highlighted thing? Can you beat that? In terms of the brevity of code, right? Just one line. Normally 20 lines, 40 lines, right? So anyway, this is just one part. This is for the developer. You spend more time with it than writing the code. So I created. Next is you can see this everywhere. It is creating the art. Don't focus much on it because I'm not in the actual class right now. Now collect is kind of an action. Okay, so how to perform, guys, you need this. Done. Vijay 58 times, Jay 176 times, Sumit. How much time did it take? See this? 0.4817 seconds. Did you just see that? Did you see that? Right? How much time did it take? It took only a few seconds. Right? So, there's definitely none of your MapReduce programs. Guys, are you able to hear me? You able to hear me, right? Great. So none of your MapReduce programs would have run in such a short time, right? Sure. There must be some of the lags individually from people. Yeah, I can understand. And I hope now you took right. Anybody who didn't understand that, how much time did it take? It just took 0.41417 seconds, right? Something which I just wanted to quickly show you. There are other features, but in the interest of time, I'm not sure right now. But I hope it should act as a good precursor that how fast Spark could be for a very simple program. And even in the complicated programs, it will be even faster. Let me quickly give you a very quick demo about Spark SQL also. Okay. So by the way, Spark SQL, let me just tell you, Spark SQL is just like Hive for Hadoop. What does it do? It allows you to expose the data in the form of a table. I was giving you an example, right? Let's say you have a file. You want to query something out of it. So you would like to expose it and you would like to do this. Who would like to work with Spark SQL? Who will like to work with Spark SQL? Definitely not a programmer. All those people who are coming from the data warehouse background, who are not good with Java, who are not good with Scala, or for that kind of programming, you know, those kind of people will definitely love. Okay, so Shashank and then people saying, I would love to work on it, right? So probably you can say that yes, you guys are, you know, coming from the background of SQL and all, and hence you would like to work on it, right? So not going much into the depth of it, I do everything is based on detail. So Spark SQL implement something called schema RDD, which helps you to expose the data in the form of the tables altogether, and that's the biggest advantage which you get. On the history bytes, all I would say is Spark earlier used to be called as Shark. As of November 2014, that project is closed. Okay, that project is closed as of November 2014 and is called as Spark SQL. The Spark SQL, using it, you can either export the tables directly, or you can even use the tables of Hive. You know, the tables of Hive. The best advantage is, you know, the same Hive query without changing code are to 10. Those are some of the advantages. On that, we'll work on those in classes. So let's not worry about this slide. In the interest of time, I'm just avoiding it. I'll quickly show you the demo of Spark SQL. Okay, I'll quickly the demo of Spark SQL, which give you an idea, you know, just taste of how it work. You know, where the or how does it exactly Spark SQL works, right? So let me just quickly go back. Are you guys enjoying the hands-on part? Right? First of all, you know, I should not just be doing it for the sake of it. What is the advantage of SQL over Hive? Sandeep, the best advantage is what is the fastest query of Hive? How much time does it take? 10 seconds? 5 seconds? It will take fractions of second. Okay, another question, how much minimum memory we need to use it on a single node as it is in memory? Well, it goes into the hardware sizing parts of, however, let me tell you, RAM are typically 50% more than whatever they are for Hadoop cluster. Got it? Saurabh? More details, you know, like it goes from the use case to use case basis, but I have given you a benchmark figure. I hope you got some idea, right, Saurabh? Well, that was a very interesting question. I loved this question. Okay, now let me just go back with the machine, the place I love. Now, let me quickly give you a quick Spark SQL demo. Again, guys, don't worry right now if you don't understand much of it. As part of the, as part of this entire Spark SQL, I eventually have to create a SQL context object. Okay, SQL context object has to be created typically. Okay, now hold on, guys. Those memory questions and all, let me answer them in a few minutes. Let me just give this demo a bit more details. Okay, now the next step, guys, see this schema RDD. I was talking about schema RDD. Everything is an RDD. You have to import that. Then right now, don't worry if you do not understand this statement. This is a way which you create the classes in Scala. Okay, there are other ways of creating the classes, but this is a case class which you are creating in Scala. It's like saying that I expect something to be represented as a class. Okay, now important thing is this. Using this statement, I'm saying val people is equal to a.text file /home/cloudera/people.txt. Let me show you what is people.txt is having. See this. People.txt is having only two fields. One is the name, second is the age. Name, age. Michael 29, Andy 30, Justin 19. Okay, so this is just the content. I am exposing it. Then right now this is a Scala context or Scala syntax. What it is doing is it is splitting every record based on comma delimiter and creating the person object for every record with the first field as the name and second field the age. Okay, and second field as the age altogether, and then just say enter. Once you do this, your people value is created together. Then all you have to do is, now see this. This is a very abstract statement, but you should be able to understand the intention. The intention is whatever people value I have created, I'm registering it as the temporary table called people. Enter. Now this entire data set has become available as a table to me. And if I do this, val teenagers is equal to SQL context.SQL. See this. Select name from people where age is greater than 13 and age is less than 29, less than or equal to 29. If I do this, I have got the result in teenagers. I want to see teenagers. So say this. Teenagers.map, don't worry about that, .collect for each println. Basically, I'm printing the names of those teenagers. And see this, these are the names. Kel and Justin. You want to verify that? Michael 29, Justin 9. Right? Is teenager RDD? Yes, teenager is an RDD. Okay. See this. Right, Gaurav? Right, others? Right? So this should give you a very quick idea about what exactly Spark SQL can do for you. Eventually, what did you do? You analyzed a file, but in a way, in that you just created a table out of it, and then it's as if you are running any complex. You can run any complex query on it. Got it, guys? So those people who are not from the programming background, if you can just expose your data in form of table, you can perform any complex analytics. Got it? This is the power of Spark, which I wanted to give you. Got it, guys? Now on the last side, not some of you would have already attended Edureka courses, but those people who are attending it for the first time, very quickly I would just like to tell you, most of the classes are online, and they are, the class recordings are going to be available in LMS. You will typically get 24/7 post-class support as well. By the way, our classes are interactive. You must have guessed by now that whenever I was speaking, I was asking for your feedback. You remember? I was continuously asking for your feedback. Please tell me yes, please tell me no, and all that stuff, right? So we have typically those interactive classes, module-wise quizzes. Yes, we do prepare all of the module-wise quizzes. Definitely there would be some sort of a project work also, and at the end of the training, get verifiable certificates from Edureka. Questions and all, I try to answer most of them. I'll still see if I can answer a few more. Just to tell you the way we plan to cover the Spark and Scala, okay, before you log off. As I told, we have created this course in 8 modules. The first 4 modules focus on creating the foundation. That is introduction to Scala, the features of Scala, the features which typically will be used, in the actual programming. And the remaining 4 modules, 5, 6, 7, 8, basically introduce about Spark, the baby steps in Spark, playing with the RDDs, and then, integrating Spark with SQL. At the same time, various other topics like, adding or would say integrating Spark with Hadoop and things like that. All of those things would be covered in the remaining 4 modules. With that, I hope, guys, you enjoyed this session, especially the India folks. You are attending it very late in night. I hope you found it good. And if it excites you enough, well, join us in the journey. And that I have all of you. Please give feedback. Do share your feedback. That is something which will encourage us as a group. With that, those guys who would like to log off, you can log off and continue. I'll just see if I can answer 1 or 2 questions. While doing Spark streaming at source side, any agent required like spouts in Storm? No. Mallikarjun, nothing. There is specific RDD called dstream RDD which needs to be created, nothing else. How far opportunity Hadoop in India? I don't think calls are more on Hadoop, even if present they are asking 6 to 8 years of experience. Well, Devi, just on those sites, I myself am looking for so many people in my team. I can't reveal my company name and other stuff, but yes, there is a huge demand about Hadoop. More than me, you should believe on Naukri, Monster.com and things like that. They will do an entire picture, right? Just to give you an answer. Can we use cache while creating the base RDD? In which cases we use cache at base RDD? Well, the answer goes up to a great length, Sai Kumar. Right now, all I would say is you would use cache at the base RDD only and only when you are sure that your initial data set is good enough to fit completely into the memory. Okay. In Spark, which one works like a combiner in Hadoop? Well, the question of combiner is invalid in Hadoop. Sorry, in Spark. Just to tell you. Okay, why? It's a long story. Okay, so that is it, guys. With that, I hope you enjoyed it, and with this I'm going to log off now. Thanks a lot. Sorry if I have missed some of the questions. Please do visit our website, do visit our Twitter handle. The support team is very much eager to hear your questions and very much eager to answer your questions. With that, logging off and waiting for your feedbacks. Thank you, guys. Bye for now. And yes, all of the recording, all of the things available on LMS, they will be available. With that, leaving now. Good night and good night for the US folks.